And I reviewed with you, we have three types of reaction, three types of supports: fixed, hinged, and roller supports. Fixed, we have three reactions. Hinge, we have two. Roller, we have one. To figure out these reactions, we have three equilibrium equations. Summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. We learned very important philosophy related to any kind of structure, whatever the kind of structure, beam, frame, or truss. We have external forces that we can watch. These external forces will create internal forces inside the building, inside each component of the building. These internal forces can be axial force, shear force, bending moment. Later, if your major is construction engineer, later you will learn also these internal forces will create stresses. And these internal forces will be used in design of the structure. The first internal force is called axial force. We need to learn 2 points here. The first one, axial force, is a force parallel to the member. This force can be pushing the member, which is compression, or pulling the member, which is tension. But the force parallel to the member. The second force called shear forces. These forces which are causing shear must be opposite. We have two opposite forces, but both of them must be perpendicular to the member. So if you have a force and this force perpendicular to the member, we can expect shear. We have a force and we have distance. If you multiply force by distance, you can get a moment. This moment would like to bend the member. So we have three different types of internal forces. Sometimes you can expect vertical load on the building, like your weight, the weight of the furniture. All of these weights are vertical weight. Sometimes we can expect horizontal loads coming from earthquake or wind. So make sure you are designing the building under the effect of lateral load or horizontal load. If you didn't, probably you can expect collapse, failure, due to the effect of wind or earthquake. First part in this topic, we are talking only about a point, only one point, specific point at a specific location. We need to figure out what are the values for internal forces. Just to remind you, the first question in the homework, we need to determine the values for normal force, shear force, and moment at specific location, like point B, D, B, specific location. Next week, and the second question in the homework, we need to draw the internal forces. Big difference between calculating values and drawing the internal forces. So today, I'm gonna focus on what are the values of internal forces, normal, shear, moment at a specific point. Last time I told you we have sign convention. We need to follow these rules. If you are talking about axial force, your arrow must make tension. If you are talking about shear, the arrow direction to rotate this member clockwise. For moment, the direction of the moment, probably, how can I assume my moment? Like this or like this? You should assume moment to make this member to smile. So I believe I will assume like this and this to make this member to smile. Anyway, let's start our first example today to see what's going on. We can expect one problem like this in the coming exam. We have a beam with external forces like 10 kilonewton and external moment 20 kilonewton meter. And the problem asked for what is the internal axial force, which is N, shear force, which is V, bending moment, which is M, at specific point called C. So I'm looking for NC, VC, and MC. Values, I need to calculate values at one point. Before doing anything related to the internal forces, first step is reactions. Guys, I would like to remind you, without reactions, you cannot pass the coming exam. Without reactions, every single problem in the coming exam, first step, you need to figure out the reactions. So please go back to the videos related to how to calculate reactions. Don't worry. During the exam problems, I will let you know. A is a roller. A is a hinge. B is a roller. You should be able to figure them out, but anyway, I will let you know in the problem. Don't worry about this point. Hinge means we have two reactions, YA and XA. B is a roller, so we have one reaction, YB. We have three equilibrium equation, summation f of x equal 0. What are the forces in x direction? XA, nothing else, equal 0. Summation f of y equal 0. So we have positive YA, positive YB, negative 10. Guys, 20 is a moment. 20 is a moment. I'm talking about forces in y direction. So 20 will not be included. Summation moment at any point equals 0. Do you remember my recommendation? Take a moment at one of the given supports. We have two supports, A and B. I'm going to take moment at the support with the larger number of unknowns. So I'm going to take moment at A, and I'm going to assume this direction is positive. Okay, go ahead and set up this equation. XA times 0, YA times 0. Guys, I'm taking a moment at A. What is the distance between XA and YA and point A? 0. We don't have distance. What else? We have negative YB time 2. And remember, your force and your distance must be perpendicular. What else? We have 10 time what? Time 4. Here is 10, and you are sitting at at A. So the distance in between is 2 plus 1 plus 1, 4. What else? Please don't forget any. Yeah, I didn't forget. No, you forget something. You included XA, YA, YB, and 10. What about 20? You have to include everything. 20 will be negative. It's opposite to your assumed positive direction. Anybody in the meeting right now can tell me what is the distance between 20 kilonewton meter, and point A? What is the distance in between? Any answer? Thank you, Mitchell. Thank you. Thank you. Yeah. Yeah. 20 is a moment. Force need distance to make moment. So I multiplied YB by distance, 10 by distance, but 20 kilonewton meter is a moment, does not need a distance, just a moment, equals 0. The only unknown, this one will be cancelled, this one will be cancelled. The only unknown in this equation is YB. The value of YB will be positive 10 kilonewton. So YB equal 10. Can you go back to the previous equation, this one, and put YB equal 10? Positive 10 minus 10 is 0. That means YA, how much? 0. Okay, what's the problem? Your reaction is 0. That's fine. XA is 0. So I am done with all of my reactions. I am done with all reactions. YB equal 10, YA equals 0. You are lucky. XA equal 0. Any questions so far? Any questions so far? Looks good. Second step. So first step is reaction. Second step, apply a section. We need to cut this beam at a specific point. What do you think? Which point? Which point I'm gonna cut this beam at? I believe we are going to cut this beam at point C. We are looking for internal forces at C. So I'm gonna cut this beam at C like this. Cutting the beam at C will break this beam to two parts, the left part or the right part. You have a choice. You have a choice. Left part or right part, it's up to you. It's up to you. You can decide what you want. So for myself, I'm gonna use the right part. It's up to you. Here is the right part. At this location, which is point C, I did my cut. At this point, which is called B, we have vertical reaction. How much? 10 kilonewton. At this location, we have vertical load. How much? 10 kilonewton. Do you have anything else on your right after you did a cut at this location? Do you have anything else on the right part of the beam? No. At your cut, we have 3 internal forces. Normal, shear, and moment. The question is, why you assumed normal horizontal? Because your normal must parallel to the member. That makes sense. The question is, I'm gonna assume it going to right or to left. What do you think? You are going to assume this normal like this or like this? You have to assume your normal as internal forces to make tension. So this arrow must be like this to make tension in this part of the beam. That makes sense. So I'm gonna assume normal to left like this. What about shear? I would like to assume this vertical arrow. Why shear is vertical? Because shear must be perpendicular to the beam. Your beam is horizontal, the shear must be vertical. So to down or to up, this arrow coming to down or up, this arrow must make this beam to rotate clockwise. So I believe this direction must be up to rotate this beam like this. V at C. The moment, I'm gonna assume this moment like this or like this. Your moment must make this part of the beam to smile. It will be like this. MC. MC. So at any cut, we have three internal forces: normal, shear, moment. Normal will be horizontal all the time. Shear, vertical. Moment. How can I assume the direction? You need to follow these rules for sign convention. Your axial force must make tension. Shear, rotate this part of the beam clockwise. Moment would like to make this member to smile. So I assume this direction. Any questions so far? Looks good. So just to remind you guys one more time, your free body diagram right now looks like this. Here is a cut. Here is point B, I think. We have vertical reaction here, 10 kilonewton. Vertical reaction. And we have vertical force here, 10 kilonewton. And at this location of cut, which is point C, we have normal. We have shear. I'm sorry, this shear should be up, not down. And we have moment, MC. Any question, guys, so far? Then we have three equilibrium equation one more time. Summation f of x equals 0. Summation f of y equals 0. Summation moment at any point equals 0. Go ahead and apply this equilibrium equation. Summation f of x. Which forces on this part of the beam in x direction? Negative NC. Do you have any other force? Are you sure? Nothing else. Equals 0. So NC equals 0. This is the first internal force. Summation f of y equals 0. What forces do you have in y direction? We have positive VC. We have positive 10 kilonewton. We have negative 10 kilonewton. Anything else in y direction? No. This one will cancel this one. VC equals 0. You are lucky. You have many zeros. I know student does not like 0. But anyway, your calculation give you 0 values. That's fine. The third one, summation moment at any point equals 0. But I have a recommendation here. Please take moment at the point of cut. and assume this direction is positive. The point of cut is C. The direction of the moment, I'm gonna assume this direction is my positive direction. Okay? If you take moment at C, NC times 0, we don't have distance. VC times 0, we don't have distance. Plus MC. Hey, NC is a force. NC is a force. Need distance. And your distance is 0. VC is a force. Need distance. And your distance is 0. MC is a moment. Do you think this moment need distance? No. So I didn't add any distance. We don't need distance. Keep going. Minus 10 times 1. This distance is 1. Plus 10, the second 10, which is this one, time the total distance will be 3. Nothing else equals 0. This term will be cancelled. This one will be cancelled. The only unknown in this equation is MC. Your value of MC will be negative. I don't care, positive or negative. 20 kilonewton meter. So guys, at the end of the problem, normal at point C is 0. Shear at point C is 0. Moment at point C is negative 20. You are done. I would like to remind you what was the required in this problem. We are looking for axial force, shear force, and the bending moment at point C. We have 2 steps. First step, you need to figure out your reactions. Second step, you need to make cut at point C. And decide you are going to use the right part or the left part. Believe me, both of them must give you the same answer. Don't worry. So normal, shear, and moment. Anybody has any question? It looks very simple problem. In the exam, you must finish this problem to the end. You must get the full credit for this type of problems. The only challenge, I believe, the only challenge in this type of problem, how to calculate reactions. Then it's a piece of cake. One more example. Do you have any question? Okay, one more example. We have a beam. This beam is pin supported at A. So we have 2 reactions, YA and XA. And B is a roller. So B is a roller, so we have only one reaction, YB. Regardless, what are the required, or what is the required in this problem, regardless. First step, we need to figure out the reactions. So let's start with reactions. We have 3 equilibrium equation, summation f of x equals 0 for the whole structure. We don't have anything in x except xa, it will be 0. Summation f of y equals 0. What do you have in y direction? We have positive ya, we have negative 6, we have positive yb equals 0. One more time, guys. 20 kilonewton meter is a moment. Doesn't make any sense to include 20 with this equation, because this equation is talking about forces in y direction. The third equilibrium equation is taking a moment at any point equals 0. I have a recommendation here for reaction. Please take moment at A. It's a support with the larger number of unknowns. And I'm going to assume this direction is positive. If you take moment at A, I'm going to cancel XA and YA. You don't need to write them. Anyway, if you would like to write them, XA times 0, YA times 0, plus 6 times 2, plus or minus YB time how much? 6, plus 20. Anybody can tell me 20 time what? Nothing. 20 time nothing, because 20 is a moment. If you have a ready moment, you don't need distance. Just put it as it is. This one, this term will be cancelled. This term will be cancelled. The only unknown in this equation will be YB. It will be 5.33. If you go back to this equation, this reaction will be positive 0.67. So XA is 0, YA is 0.67, YB equal 5.33. Reactions. Reactions. I'm still saying reactions. Without reactions, in my opinion, as your instructor, without reactions, you will never pass this course. During the exam, if I'm feeling you cannot calculate reactions, you will never pass this course. If I'm teaching you how to read, the first step, you have to figure out the letters. A, B, C, D, E. Without letters, you cannot read. Without reactions, you cannot pass this course. Second step. We are looking for what are the internal forces. Normal force, shear force, bending moment at points C and D. We have 2 points. Okay, let's start with the first one. Let's start with the first point. Let's start with point C. Guys, do you remember what should I do next step? I need to do a cut at point C, because right now I'm talking about point C. So I take cut at point C. We have 2 parts. The first part, this red part. One of you will ask me, what about point D? I forget it right now. Please forget the second point. I'm talking about only 1 point, C. So I will forget anything else. The second part is this part. We have 2 options. After you did your cut, we have 2 options. To work with the right part or to work with the left part. It's up to you. For me, I'm gonna work with the left part. Very simple, very easy, very small. Here is the left part. At this location, we have cut at point C. At point A, we have 2 reactions, one vertical and one horizontal. The horizontal one is 0, the vertical one is 0.67. At your cut, at the cut, we have 3 internal forces, one called normal at C, the second one called shear at C, the third one called moment at C. Sorry guys, moment at C. we need to figure out the directions. Do you remember how can I assume normal like this or like this, to left or to right? I don't know. I don't know to left or to right. What I know, I need to assume normal to make tension. How can I assume NC to make tension in this part? Tension, pulling out. Pulling. It should be like this. That makes sense. One of you will say, hey, the last problem, you assumed the positive direction of N to left. In this one, you assumed it to right. Which one? Guys, I told you not to left or to right. I told you we need to assume it to make tension of the investigated part of the beam. You decided to make or to work with this part. Please go ahead and assume your normal making tension to this part. What about shear? Your shear must make this part of the beam to rotate clockwise. I think if this force coming down, this part can be rotated clockwise, like this. For a moment, we need to make this part of the beam to smile. Here is the direction of the internal forces. So please, after you are done with the reactions, the following steps is or are: first, we need to make cut. Second, we need to decide which part, this part or this part. Third, we need to put the positive directions of the internal forces. Direction of the internal forces, you have to follow the sign convention. Your normal must make tension. Your shear must cause clockwise rotation. Your moment would like to make this member or the investigated member to smile. Guys, do you have any questions so far? It's a good question, Mitchell. You don't need to figure this out because the problem will tell you. We are looking for internal forces, normal, shear, and the moment at point C. So I need to follow what is the required at point C. That's it. It's not my opinion, it's the problem. We'll ask you a specific point. In the previous example, we are looking for internal forces at this point. So I need to make cut at this point. Now we have a point C. I will do cut at C. Okay, go ahead and apply summation f of x equals 0. You will find NC will be 0. Summation f of y equals 0. So we have positive 0.67. We have negative VC forces in y, 0.67, and negative VC equals 0. So VC will be positive 0.67. The third one, summation moment at any point equals 0. But I have a little recommendation here. Please take moment at C and assume this direction of the moment, which is positive. So if you take moment at C, VNC times 0, VC times 0, MC does not need distance, and negative 0.67 times 1, because this distance is 1. The only unknown, because this term will be cancelled, this one will be cancelled, the only unknown is MC, so I can figure it out, 0.67. Positive 0.67. So finally, I am done with the internal forces, normal, shear, and the moment at point what? C. We have another part in this problem. We are looking for internal forces, normal shear moment at point D. At point D. Where is point D? Here is point D. So, for point D, I will assume I am done with my reaction, and I will forget we have a previous point. Forget it. Here is point D. I will do a new cut at D. We have two parts. The left bar or the right part. Guys, be careful. And the left part. One will say, hey, we have a point C, please. Forget we have a previous point. I will assume I didn't do anything here. I just finished my reaction and I'm talking about D right now. It's a different point. So I didn't know what is the meaning of C. I don't care. Okay, so we have two options. If you cut at D, you can use the right part or you can use the left part. One more time. One of you will say, what about point C? Please forget that we have a point C. I don't care. I believe the right part will be more easy. So the right part will look like this. Here is the cut at point D. We have here vertical reaction 5.33 and the moment 20. At your cut, we have three internal forces, one called normal at D, one called shear at D, and the third one called the moment at D. Normal, shear, moment. How can I assume the directions? Normal would like to make tension in this part of the beam. Shear would like to rotate this part clockwise. Moment would like to make this part of the beam to smile. Then go ahead and apply summation f of x equals 0. We have negative nd equals 0. So nd will be 0. Summation f of y equals 0. So we have positive VD, we have positive 5.33 equals 0. So VD will be negative 5.33. Summation moment at any point equals 0. But please take moment at D, assume this direction is positive. This direction looks like this direction. So ND times 0, we don't have distance. VD times 0, we don't have distance. MD, we don't need distance. Plus, we have 20. We don't need distance. We have negative 5.33 times this distance. How much? 2 meters. One will say, someone of you will say, hey, why 5.33 times 2 and 20 times nothing? Because 20 is a moment. does not need distance, but 5.33 is a force as a reaction need distance. The only equal 0. The only unknown in this equation, this one will be cancelled, this one will be cancelled. I can figure out the value of MD. It will be, I think, negative. I don't care about positive or negative. 20 minus 9.33. So guys, finally, I figured out the internal forces at D: normal, shear, and moment. Any question? Very simple. Very simple problems. If you can figure out the reactions. This one, I believe I covered this kind of problem in the reaction module. Do you remember? Anybody remember what is the meaning of this member? Two force member. What do you mean? I mean, I can delete this member and draw this beam like this. At point B, we have one reaction, or this reaction in the same direction of this member. At point A, we have hinge, so we have two reactions, XA and YA. And we have uniform distributed load. 5 kilonewton per meter. This angle is 45 degrees. This one will be 45 degrees. So we have two components here, the horizontal one and the vertical one. R sine, R cosine. Anybody remember how can I convert this distributed load to equivalent one? It will be here. How much? How much? 5 times 6, 30 kilonewton. Go ahead and figure out the reactions. Summation f of x equals 0. So xa plus r cosine 45 equals 0. Summation f of y equals 0. So ya plus r sine 45 minus 30 equals 0. Take moment at A equals 0. Assume this direction is positive. So we have r sine 45 times 3 minus 30 times 3. So I assume this one and this one will be cancelled. The only unknown in this equation is R. So R value will be 42.42. So R equal 42.42. So the vertical component will be 30 and the horizontal component will be 30. So this reaction will be 0 and this reaction will be negative 30. XA will be negative 30. Negative means in the opposite direction. YA will be 0. So guys, the final conclusion for this beam, something looks like this. Here is the final conclusion. Here is point B. Here is point A. We have horizontal reaction like this, 30. Like this, yeah. You assumed it like this, and your answer is negative. So the correct direction must be like this. This reaction is 0. We have here R. This R give you vertical reaction 30 and horizontal reaction 30. And we have uniform distributed load. 5 kilonewton per meter. I'm gonna forget this R because you already have vertical and horizontal one. This is the first step, reactions. I didn't read the problem. Okay, go back and read the problem. We are looking for axial force N, shear force V, bending moment M at point C. Here is point C. We have here a point called C. What should I do the next step? Make a cut at C. Make a cut. We have two options. The right part with all of this stuff, or the left part with very little stuff. What do you think? This distance is 1.5. I will decide to take the left part. I did cut here. What do you have? I have vertical reaction 0. I have horizontal reaction 30. I have a little bit of the uniform distributed load. And this distance is 1.5. At the cut, we have normal, we have shear, and we have moment. Don't forget, we have a little here of uniform load. We have 5 times 1.5. How much? 7.5, yeah. Go ahead and apply summation f of x equals 0. NC will be 30. Summation f of y equals 0. VC will be negative 7.5. Summation moment at point C, and I will assume this direction is positive, MC will be negative 5.625.